31 February 21st. Well, I just watched Liverpool got thrashed. Literally thrashed. I mean, I didn't watch the game. I just watched this highlight. What I can see is there's just no energy in there. There's no legs. They don't have any legs. They probably play well at the very beginning where they scored twice, which says a lot about the fact that the team does play well if the players can run. But later on, you can just see Modric outran an 18-year-old. Hey, how is that even possible? Well, it is possible if Real Madrid really did a very good job preserving the players, and Liverpool, I mean, we all know Jurgen Klopp's style of playing is very hard on the players. High pressing from very early on in the game, and then I can see that a system will work for a team if it has enough drive, and for the first few seasons, but it's not a longevity. Yeah, it's not a longevity. Just burn hard and then burn bright, and that's actually happened to it happens to Dortmund as well. At the end, I don't think it can continue, and they don't buy new players very often, so there's no constant rotation, and then this is what you have. Oh, Modric is a good player. Yeah, I mean, but Modric is 37, so you can't really say anything. All right, capacity to ship package within D days. Conveyor belt has packages that must be shipped from one port to another within days. The ith package on the conveyor belt has a weight of this. Each day, we load the ship with packages on the conveyor belt in the order given by weights. We may not load more weight than the maximum weight capacity of the ship. Return the least weight capacity of the ship that will result in all packages on the conveyor belt being shipped within days. So we're going to do this one by one, right? Then each day we load the ship with packages on the conveyor in the order given by this. We not load more than. Okay, so of course if we have a giant weight, and then we can load everything in one day. And now we say we can do in 5 days, right? So of course, if you want to do, at least it has to be the highest, right? At least it has to be the highest. Basically, you just want to say, I want to divide this into 5 subarrays, and I want the maximum sum of each subarray to be as small as possible. That's what we want to do. And for 5 days, we're just going to insert 4 into it, right? 4 into it. I mean, what we can do is let's see. So it has to be following this, right? It feels like binary search. Basically, you get a value and you try to see if it fits, right? Is it 15? Then you're gonna just fit as much as you can. Well, I mean, we start with total sum and we have a value. Then we try to ship. But of course, we know the minimum value. The minimum value has to be the smallest, right? That's the minimum value. Yeah, that's the minimum value. And highest value, just add them together. And then we get our first value, right? And we try to see if it's possible by doing, we might be able to, now we can just search. We just go from the first one, add, and then we have 6, 7, add 8, 9, 10, right? This is 3. 3, we have 1, 2, 3, 4, 5, 6. No, 3 days. 3 days was 6. So that's 1, 2, and 3. So yeah, I think binary search shall do. I'll give a binary search a shot. Alright, so we're gonna have I can just low 1, high equals 1, and the sum weights plus 1. And while low smaller than high, mid equals low plus high divided by 2. Right, and then we're gonna say if it's good, so say d equals 0, right? And then we say for w in weights, right? And then d equals s equals, so s plus equal to w. And we say if s is larger than mid, then d plus equal 1, right? And then s shall equal to w. And then coming out, whatever's the last one. Oh, we should say if d plus equal to s larger than 0. Then we say if d is smaller or equal to days, right? Then we can push it lower because we're good to go, right? So if that's the case, then we say high equals mid. Else d is too big, and d is bigger, then we need to raise it up. I'm gonna say low plus equal 1. Now return what? So when high goes, it's always good, right? High goes here, and low is not good, so we'll plus equal 1. So I think we'll just return low. Six, 3. Weights, days, ship. Oh, the last one's not right. The result is 2. Answer is 3. Is the binary search thing. We see. Result is 2. Reason 2 is going to be not enough, right? If mid equals 2, I mean, so low equals 2. Okay, let's check the last one. See what happens. Okay, 1 and 5. Well, 5 is too big. D is smaller, so high equals 5. 1, 5 is 3. Oh, 3. That's the problem. 3. We have 1, 2, 3 days. Oh. Okay, hold on. So we have 1 plus 2. Larger equal to. Oh, if it's equal to. Hold on, if it's larger than. It's fine. If 1 plus 2 is 3, so now a plus 3 is 6. 6 is larger than mid, so day plus equal 1, and s equals 3. Then we come in. We add another one. It's larger, so s should be 1, right? And then 1 coming out. Actually, it's not right because at the end, we have to see. Oh, but high is equal to mid. That'll be 3. And 2. 2 shall not be good. What? 2. 1 day, 2 day. What? Dude, this is not right. Mid is equal to 2. So we start. First is 1, is good. Now it's 3. 3 is larger than 2, so D becomes 1. Alright, S becomes 2. Comma be 5. So D becomes 2. Alright? Then S becomes 3. And be 4. Right, so D becomes 3, it's become 1. And then it's already D is 3, but the thing comes out. Nope. I don't think that's. Nah, actually we should do it. We should do it better. So how do we do this? For each weight, right? I should check it first, right? I should check it first. If it's good, then we do it. Okay, how about we check it first? We say if S is larger or equal to mid, right? Then D plus equal 1, S reset. Then, no, we should be if S plus W is larger or equal to mid. If S plus W, so whatever we have is current so far, and then we add the current one. If it's larger or equal to, well, if it's larger than mid, if the sum is larger than mid, then S will equal to W. Go to the next one. Okay, now if S plus W is equal to mid, then D plus equal 1 as well, and S will become 0. Right? And then if it's smaller, then we just else S plus equal to W. So 3 situations, right? So the first one would be this. And then once we come out, we'll have an S. Well, of course, there's also one more situation. That is, if any W, right? So that's what I said. That's what I should do minimum weights, not minimum weights, maximum weights. At least. So that can prevent this from happening as well. And when we get out, right? S equals W, and then when we get out, or S equals plus equal now when we get out, because that's the last one. So we haven't checked the last one. So all we know is, oh yeah, we basically did, because if plus this is larger than this, then we'll add the previous S, right? And that will be remaining as W. And then we can do this. This, I think, this is right. This is right. This is right. I think I can do this. If S plus W is smaller than mid, S plus equal W, right? Else D plus equal 1. S will equals W if S plus W is larger than mid, else 0. So I can just say times int. And then I can simplify all this. And D, this. Okay. Ooh. Doesn't look nice. Wow, it's pretty strict. I thought this would be sufficient. Yeah, I thought this would be sufficient. All right. I mean, I know because this we're repeatedly doing stuff. So, all right. I was trying to be, I was trying to be lazy. Okay, from collections, accumulate. So I think a accumulate shall help, right? The prefix sum. Right, prefix sum. If I know prefix sum, then all I need to know is the mid. Find the mid, so first thing done, right? And then the remaining, I want to know the remaining, and it's just mid plus the whatever is the first, and that's like the current. And then okay, so I think we can do pre-sum equals list accumulate weights, and we need from bisect, import bisect. I don't know, right? Right to left. Okay, so mid is this, so we don't need this anymore. What we need is bisect left, pre-sum. Carry C star is 0, so it'll be C plus mid, right? So this will give me an index. Okay, so if in the start we have an index, so if it's the same, or it will be always on the left hand side, right? It will be always on the left hand side, and because everybody is larger than 1, so it will not be the same. And what we want to know is how many can we do, right? How many can we do for the first? So we have index, right? That's the first, like these can be loaded on one day. Then we need the second day, the third day, the fourth day, right? So what we need to do is d is still equal to 0. Okay, and then what? Then what? Okay, while true, index equals this. Okay, and then we can find somewhere in this, right? We find somewhere, and then d plus equal 1, right? And c plus equal 2. C plus equal to, ooh. What we want to find is after this is gone, it's like this part, right? This part. So from this part, that will fit. Yeah, C will plus equal to pre-sum index. Index is here. It's actually index minus 1, I think. That'll be index minus 1. Alright, that'll be index minus 1. Well, add this is C. So, because this one we haven't included yet. And next time, C plus mid. Right? Next time, C plus mid. Actually, C should be here. C equals. Right, next time C plus mid, we get a new value, and then we try to check where it's going to be, and then we'll do this. So eventually, right, eventually the second time, and see it here, and then the next time is there, and then the next time. So it will end when index is, so my C plus mid is larger than pre-sum. Larger than the largest one of the pre-sum. Right? Pre-sum is this, and then we add this one, another day, and then it goes beyond. So equal to this. Oh, equal to this. Equal. That's not right. If equal, it shall count. So it should be right. Right? If it's equal, I shall do this one. Instead of the left, I should do the right. Because everything that will be equal to this. Right? So these all shall be. So if it's equal, then the index shall be this. Index minus 1. Still holds index minus 1. Yes, index minus 1. And then its equal will be on here, right? On the right hand side. And then d plus equal 1, right? And then c plus equal 2. So if c, while c is smaller than pre-sum minus 1. And then we do this. All right, let's try this one. Accumulate from collection. Collections, that's not collections, it's a tools. Eesh. Ugly, ugly, ugly. Very ugly. All right, so I mean, that happens. Nothing to be worried. We are using a new method. 1056 and 33. What do we get for 33? 33, we got 2 days. 15, we got 3 days. All right, that's not right. 15, we got 3 days. So we need to take a look. 15, do you need to use pre-sum? Right, because I say from this from this to this, right? This to this, from this to this is this minus this, right? This minus this equals this. Think about it. We're talking about, right? We're talking about this. So talking about if I first one, right? If I get 15, okay, so 15 coming in, I will get pointing here. Then d plus 1 day, right? And I say c plus equal to this minus 1. So c will be plusing this, will plus this, will plus 15. Because what I want to find out is this, minus 15. Right, we can actually check the index and see what did we do wrong. Index. All right, find 15. So first find 5, 0, 1, 2, 3. 0, 1, 2, 3, 4, 5. That's right. Second, I found 7. 0, 1, 2, 3, 4, 5, 6, 7. I find here. 36. Okay, that's 36. What we have is 15 plus 15 is 30. So we're trying to put 30 in. So 36. Let's see if it's correct. 6, 7, right? 6, 7, because we cannot do this. So 6, 7, that's actually correct. Next one is 10. Okay, next one is 10. So it'll be 7, 8, 7, right? 7, 8, 9, 10. So next one is here. Wait, hold on. What? 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5. Right, now we take this. And then 6, 7. Now we take this. 8, 9, 10. That is bonkers. Oh, C equal to. Not plus equal to. C equal to. That shall do. Yep. All right. New solution. It's a binary search within a binary search. Double binary search. $93. So this one shall work. Man, don't tell me this is still too slow. Huh. That is unexpected. I did not expect this one to be too slow. The hell? Try one more time. Maybe one of those times it will pass. No. What can we do? Wait, I don't know. I I literally have no clue. I have no clue. Okay, that's one way. Let's say we don't compute this, we just get, you know, we get to 1, and this we get to, I don't know, what's the maximum? Maximum is 500, so 10 to the 6, 25, 25, 10 to the 6, 1, 2, 3, 4, 5, 6. Okay, but then we have to do some things. Yeah, we have to do something. I have some value. So basically we stop here, right? We get a value, then we calculate. Okay. And then it'll be, I don't know, to what? Let's see what happens. Okay, this one pass. What happened? Does this one not pass? He didn't even print anything. I don't know what happened. Oh. I think what happens is when we do binary search, something is, you know, it's too big. Right? Then we shall go down. Then it becomes too small. It's smaller than the largest one. So what's gonna happen if it's smaller than the largest one, which means C is gonna be 0. Alright? If C is going to be 0, so while C has, not C is 0, its index becomes 0. Okay? So index becomes 0. That is not possible. So we say if index is 0, then we say that's just too small. Alright, so D equals math.inf, and it will break. Oh, still not right. It's just nothing prints out. Why nothing prints out? I don't know. Let's run 10 times. See what happens. What the hell? What the hell is this? Oh, low plus equal 1. What the hell? I can't, man. I cannot even speak of this. Dude. I've never seen you make an even more stupid mistake. Jesus, man. It's mid plus 1. It's mid plus 1. Oh my god. It's like, dude. Can you just not be so dumb sometimes? I don't know what happened. How would I say low plus equal 1? My god. Now we don't need this. Double binary search. Use outer binary search, right, to find the capacity, right, of the ship. Use a inner binary search to verify whether the current capacity is good enough. Now is valid. Oh, log in times log in. This one should be faster because we don't have to do the stupid check. This stupid check. Oh, I didn't have the stupid check here. Oh. So it's all good. Yeah, it's all good. All right. Solution. And login doesn't work. They do a feasible. Yep. Sorry, Python is can't do this with Python. Nobody complain about Python not passing, huh? Well, nobody's using Python. What does hot mean? Oh, it's just me. I don't believe it. I don't believe it. I do not. I refuse to believe my solution, which is exactly the same as this one, and it did not pass. That will be bonkers. I mean, we'll try to see if they pass. It's fast. It's fast. What did you do that I didn't do? For I weights left get a maximum. I did that too. Right. I did that too. Oh, this thing. Now, this is the wrong thing. This. I shall exit earlier. Okay, it's not me then. Oh, it's not the problem, it's me. The problem is always with me. Early exit, I think that's the issue. So basically, and then we can say if D is larger than days, then we can just break. Right, then we can just break. Oh, and oh my god, mid. Oh, now we understand what happened. That's why it takes so long. You forgot the mid. See? You see? It all boils down to one thing. Okay? All boils down to one thing. All boils down to one thing. Dude. Alright. That's an easy problem. I just forgot it. I bet even if I don't do this break, actually I'm gonna try. Without early break. Yes, that should also work. Yeah, I think it should also work if without breaking. Yeah, slightly slower, but it should also work. But dude, I don't know what to say. Yeah, shut up. All right, let's take a look at this and then we'll call it a day fast. Minimum cost to split an array. You're given an integer array nums and an integer k. Split the array into some number of non-empty subarrays. The cost of splitting is the sum of the importance value of each subarray in the split. Let trimmed subarray be the version of the subarray where all numbers what appeared only once are removed. Be the version of the subarray where all numbers which appear only once are removed. So 3, 1, 2, 4. So 1 and 2 appear once, so 3, 4, 3, 4. The importance value of a subarray is k plus trimmed subarray.length. For example, if this, that's 1, 2, 3, 4, 5. 5 plus k. Return the minimum possible cost of a split of nums. Some number of subarrays into two subarrays. Importance value, so is 2. This is 4 plus 6 is 8. Who thought about these type of things? Alright, it's without a doubt it's a DP problem. Right? It's a DP problem. You just need to find the right state to describe the problem. So we want to divide this into certain number of subarrays, right? And after we split, we need to find total numbers trimmed. Damn, trimmed. How do we handle trimmed? How can we do trimmed? Okay. Then I want to know the minimum. Is that a recurring problem? Yeah. Like if I decide the first one I'll put somewhere, okay? I'll say, yeah, let's say if I want the first one become 1, 2, 1, all right? Then the minimum possible cost will be the minimum cost for the remaining plus the cost of this, right? So, okay, that's reasonable. But for each one, I have the first, this one, and this one, this one, this one, right? And basically, I want what will be from this down, okay? From index down, what's the minimum cost of splitting, right? The minimum cost of splitting from this one down. Now to find the minimum cost of splitting, I will split this. Then I need to find out the trimmed array of the current subarray, right? Which means if I know immediately what this is, that will make things a lot easier. So trimmed, So basically, if I can know, given a pair of index, can you tell me the length of the trimmed subarray of that? Well, if I do go one trip down, from here to one trip down, can I do that? Just brute force it. Hey, one, that would be 0, that would be 0, that we have so we need to add, that's a 2, and that's a 4, that's right, so we just plus, right, plus. If it exists, just plus. If it exists, plus. So I will do a count of everything, and then, so here is kind of how I'm thinking about this problem. Right, so I'm gonna build 2 DP for this. Right, so we have a DP is going to be, okay, so 0 times n for this range n. right? So that's the outside DP. Now what I'm gonna do is for I in range n. Okay. Then for j in range everyone by itself is going to be 0, right? So for j in range I plus 1 to n, right? Then at the beginning, we can say scene is going to be a set, right? Set of nums I, and the trimmed length is going to be 0, right? At the beginning it's going to be 0. Then we say if nums j is in scene, okay, then trimmed length plus equal 1, else scene.add nums j. So blah 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 blah. Once we're done, we say dp ij, okay, from I to j. Ooh, dp ij is here, right? If this dp ij shall equal to trimmed length, right? So once we're done, then we have trimmed length. Let's print dp, a row in dp, and then print row. Let's just take a look, okay? Take a look. Let's see how it looks like. Okay, so this is going to be nums. It's nums k again. Earlier, I think we have a nums k already. Min cost nums k. All right, I just want to do this. Okay, let's see. 0, 0, 1, 2. That's not 2. That's not true. Okay, this is not helping, man. 0, 0, that's not 1. Okay, that is not 1, so that's not true. So we need to have a counter. How would the counter work for this? Because I need a little length, right? So if I have counter, then I can keep track of the length. But I have a total length already, so every time I have it, I should add to it. But you don't know. Oof. So the first time it's seen, you need to add 2, right? First time it's seen, you need to have 2. And at the subsequent scene at 1, but you don't know the first time scene, so therefore you have to use a counter. All right, so counter equals counter, and we say counter nums I equal 1. Trim is this, right? And then we just say counter nums j plus equal 1, right? And we say if counter nums j is equal to 2, then trim the length plus equal 2. Okay. If counter nums j is larger than 2, then trim the length plus equal 1. Otherwise, we don't do anything. And then we do this. Now let's see. 0, 0, 2, 4, 5. 5. 1, 2, 3, 4, 5. 7. That is correct. And then from here, it will be 0, 0, 2, 4, 4, 6. And then 0, 0, 2, 2, 4. Nice. From here, 0, 0, 0, 2, 0, 0, 2, 0, 2, and 0. Okay, so that's our DP. Now we're gonna def helper. So we're gonna start from the index, right? So from index to the end, I wanna know the smallest. So this one will kind of return an integer, right? Okay, so we say if index is equal to n minus 1, which means we are looking at the last one. So that's k, right? Because if 1, it's only 1, so the 0 is k, right? Otherwise, we can say from index, we can say for I in range, because I want to do by myself, right? Or I get next one, or I get next one. So in the index plus 1 to the end. And every time, right? Every time we're gonna do the rest is equal to math.infinite because we want to find a minimum, right? So every time we can say helper I, right? Helper I give me the minimum of the remaining, and rest can equal to the minimum of rest, and I will do from index to I, right? Index to I, which is dp index to I. This is the length plus k plus this, and then we'll return rest. And we're gonna do from func tools import LRU cache. I'm gonna cache this baby. Then we're gonna call return helper 0. Alright, let's see if it works. Ugh. It does not work. Okay, okie dokie, okie dokie, okie dokie. Alright, so we're gonna from index. Okay, so I is index and helper we're gonna do plus 1. How about this? This one works. Oh, I was about to celebrate. I was so close. I was so close. I was about to celebrate. All right. How is this one? 1, 2, 1, 2, 1. K equals 5. Huh. I see. If it's okay, if index is equal to n, shall return 0. Okay, how about this? There we go. There we go. We might actually solve this. Unless he tells us time TLE. Please do not TLE this. Please do not TLE this. Yeah, doesn't look promising. It's one of those things. Dude, seriously. Seriously. It's forcing me to coding in different language. This is unfair. This is unfair. I don't know. I mean, what, we don't do LRU cache? We do another round? Alright, this is unfair. It TLE'd. It passed everything. I passed every test case, but just barely TLE'd. All right. I mean, if we can do it this way, we can definitely do it bottom up. So we're gonna do it bottom up. So DP, actually I'm gonna call the first one DP trim. Next one DP value. What's that's called? DP price. Okay, so the DP price is actually should be 0 times n. If you think about it, huh? Actually by n plus 1. Right? And we're gonna go from back to the front, right? So we say for I in range, I don't know, n minus 1, right? 2 minus 1 minus 1. For h1, for j in range I towards n, okay? Then res equals math.inf, and then res equals minimum res, then dp trim I j plus k plus dp price I plus 1. Nah, math.inf and then dp price minus 1 is 0. Now I don't need this. We just dp price I equals minimum dp price I plus this dp price I plus 1. And then once we're done, we're gonna return dp price 0. Yeah, it's not fair, but and right. How come? How come? So we start with n minus 1, right? 14, 10. I will start from minus 1, which is and then will be this, and then dp trim ij of itself will be 0 plus k plus I will be 0. So yeah, I don't see. Let's print dp price. There's 2 how about this? 4. Oh, it's not I plus 1. It's j plus 1. All right. So this bottom up. You better not TLE this one. It did not TLE. Well, it's bad, but it did not TLE. Alright, there's room. Luckily, this did not TLE. But runtime. The runtime is pretty bad. Which means we cannot just let it go. We have to keep working on this. Anyway, maybe we can do better here, right? Maybe this one we have a better way to do this. You don't have to go. Maybe, you know. Yeah, we can do better here. But we'll leave this for tomorrow. All right.